Amanda. Is there a way to check your work other than what?
Other than like is there a way to check?
I mean, checking it in your calculator is the way that I would tell you to check your work. So like you need to show that two things are true, like for number one or whatever, your answer, sign of your answer should give you 0.11 on the calculator. And your answer should be between pi over 2 and 3 pi over 2. That would be my check, and I would do all of that on the calculator. Is that what you're asking? Okay. Aria.
For number 11 on work type 4, how does she get your answer?
Oh boy. I mean, math? What are we being duty about, computer? All right. So worksheet 1. And then I'm going to need the unit circle for this. Let's grab that. What the heck just happened? Okay, and you said number 11, Aria?
Yeah.
Okay. So if I draw my picture, 0, half, 1, 1.5, 2, 2.5, 3, 3.5, 4. So we're looking in quadrants 3 and 4. I do my all silly turtles crawl, and I know that tangent is positive in quadrant 3. So there's my theta. And so I'm going to go to I remember that tangent is y over x in my unit circle. And ideally here I'd be looking at the place where the y coordinate has a root 3 in it and the x coordinate has a positive or a regular 3 in it. But there is no place on my unit circle where there's a positive 3 in any of the coordinates, right? So I'm going to have to do a little reducing. I know that regular old 3 I can think of as root 3 times root 3. So I got to reduce that down to just be 1 over root 3. So I'm going to look on the unit circle for a place where the y coordinate has a 1 in it and the x coordinate has a root 3 in it in quadrant 3. I don't care about any of the signs because I've accounted for the signs by figuring out the quadrant I need to look in already, so I don't care about the signs. So looking for the place where the y is 1 and the x is got a root 3 in it is here at 7 pi over 6. Come on. Ugh, I hate this machine. So far, so good. Come on, pen. Come on, pen. But notice that I go around 1 full time before I get to my answer. So I really have to be adding 2 pi to that. And when I make a common denominator and add my fractions, I end up with 19 pi over 6. Is that okay, Aria? Was that a yeah or no?
Yeah.
Yeah, you're good? Okay. Alexis?
I think that means the answer key's wrong then, because the answer key said 11 pi over 6.
Okay, and the answer key's wrong. My apologies. Tommy!
Can you do number 10 on worksheet 2, please?
Sure. All right, we'll start by drawing our picture. Again, I'm only going to write down the parts that I need because there's kind of a lot of coordinates to name. I noticed right away that the theta is negative, so I should be going clockwise while I'm doing my naming. So 0, negative half, negative 1, negative 1.5, negative 2, negative 2.5, negative 3, negative 3.5. So we're talking about those two quadrants. All silly turtles crawl tells me that sine is negative in quadrant 3. When I draw my theta, again, it's negative, so I have to make sure I'm drawing this clockwise. So round to negative 2 and then to my answer. So there's my theta. My alpha is always the acute angle formed between the x-axis and my terminal side. And now, to figure out what theta is, I'm going to be taking this end of the x-axis that makes up my alpha, so negative 3 pi. And then since theta is negative, and I'm crossing the vertical axis, I should be adding, alpha. And then it's calculator time. So negative 3 pi plus, and remember the alpha is always the absolute value of the inside, so I'm just going to do sine inverse of 0.44 rather than negative 0.44. Always the absolute value though. So I get 1668. And if I did sine of that, oh my goodness. Nope, what mode am I in? Yeah, the wrong mode is what the answer is there. There we go. Negative 897. This seems much more reasonable. It's like, how am I getting a positive answer? That's not right. There we go. So if I do sine of that, I should be getting back negative 0.44, which I do. And then if I take 7 pi over 2, that should be smaller, which it is. And negative 5 pi over 2 should be bigger, which it is. So I'm quite convinced that I got the answer I'm looking for. That feel good, Tommy?
Yeah, thank you.
Yep. Maddie?
Can you explain how you chose 3 pi for that one? Like to do minus 2 pi?
Yeah, so this is my alpha here, right?
Mm-hmm.
I'm going to use whatever part of the x-axis makes up alpha.
Okay.
That's what I'm going to be adding or subtracting alpha to.
Okay.
Is that cool?
Mm-hmm.
So just coming from my picture. Jacob.
So if you give us like one.
So if this was, say, hypothetically, theta equals cosecant, let's do negative 1.44 because you can't have cosecant of 0.44 or negative 0.44. So what we'd be saying here then is this is the same thing as cosecant theta equals negative 1.44. And I know that sine is the reciprocal of cosecant, and cosecant is the reciprocal of sine. So sine theta is equal to negative 1 over 1.44. So theta would be sine inverse of that. And then obviously my alpha is going to be the absolute value around all that nonsense. And yada, yada, yada. But that's, you were asking about just that piece, right? This is like a complete aside, but that's okay. That answers your question, though, about what to do with with one of these reciprocal ones. Is you got to rearrange it till you get to this, so you can use the inverse on something that's on your calculator. Because the catch is cosecant inverse isn't on your calculator, right? There's no. operation for that programmed in. I don't know why they didn't bother to do that, but they didn't. Probably because the algebra is not hard. And it probably would take a lot of memory. Like the power series function that's doing the approximation is probably pretty long. Probably need a lot of terms to get the kind of accuracy that you really need out of. So it's probably a big memory drain. This is my suspicion, but I don't really know. Jacob.
So when you set up the it's always the absolute value, right?
Right. So inside of your alpha, we're always going to do the absolute value of whatever it is. Yeah. And that'll always work out for us. Anybody else? All? Number 7 from worksheet 2. Sure. Again, we notice that this is negative. So we're going to be going and writing our labels clockwise. So 0, negative 1/2, negative 1, negative 1.5. So we're looking at quadrants 2 and 3. Oops-a-daisy. When I do all silly turtles crawl, I see that sign is negative in quadrant 3. So I'll draw my alpha, or draw my theta. Again, I'm drawing clockwise because I know theta is negative. So my alpha is here. So alpha is sine inverse absolute value negative 0.56. And to write my equation for theta, since the axis that makes up alpha is negative pi, I know that's what I'm going to be adding or subtracting my alpha to. Since alpha is negative and the last axis we passed was the vertical, I'm going to be adding alpha. And then it's calculator time. So negative 255.
So would you add or subtract? So you add alpha because it crosses over.
It's negative angle, and it crosses the vertical last.
Okay. Gotcha.
Right, immediately before we get to the terminal, it crossed the vertical. If it was a positive angle and it did this, then we'd be subtracting alpha.
Yeah, okay, I see it.
Luke!
So when you when the last thing crosses is the vertical, when it's positive, you're subtracting.
So if theta is positive and our last axis passed is vertical, we're subtracting. If the last axis passed was horizontal, we'd be adding. If theta is negative, everything is reversed. All sticky keys. That's what you're asking about, right?
Yeah.
Okay. Paul? Well, negative 0.59 isn't between negative pi over 2 and negative 3 pi over 2. So I know that it can't be right.
How many times to like make that circle? How do you know how many times it goes?
Well, when I'm writing my labels, it's how many times I've gone around to write my labels. So like this one, I just went, I didn't even complete a full-time round to do my to do my labeling, so I didn't have to go around more than once. On this one, 0, -0.5, -1, -1.5, -2, that's one full-time round. I haven't drawn anything yet. -2.5, -3, -7, so I went one full-time around and then went to my answer, because I went one full-time around on my labeling before I got to the end. Does that make sense?
Yeah.
So again, it's just coming from like my picture. Yes, Maddie?
The labeling is what basically is in between is two negatives, like a negative, half pi and negative pi. Like you would go clockwise for labeling, right?
Hmm.
And then it's positive, you go counterclockwise.
Just like when you draw your thetas. Same rule. Yep. Paul?
I figured it out. Key and the regular which.
Oh,
I
sure.
used the key to like help me through. So I was using the problem from the key.
That would explain it. That would explain it. Arya?
The thing you just taught about like cross, it's like I don't need to know that.
You can look at the picture and figure out whether you should be adding or subtracting also. Yes, it does not matter. Now, some of us don't like to do that. Some of us have trouble looking at the picture and figuring it out. And it's like, yeah, I just want to memorize that. That's fine. You know, we started out by just kind of looking at the picture and like using our noggins. And then people were like, wait, what? And I'm like, well, you could also do this. And they're like, oh, okay. But yes, use your noggin. Don't underestimate just sitting there and thinking about like, does this actually make sense? Because most of the time, like, it's not that complicated to have kind of figured it out, especially once you've done it a couple of times. Plus, you have the checking ability, right? Like if you're like, oh, maybe I should have subtracted instead of added, and then you check that and it works, it's like, I guess I just didn't remember it right. You know what I mean? Like, there's really only two options if you set it up right, whether the mistake is probably the add versus subtract. As long as you have that, you know, you can check it and be like, oh, check. Guess I should have done the other one. You know what I mean? You know, that helps. Last call on this. Okay, marginally more ready then. All right, it's go time then.
I'm literally marking right now. You can't believe I'm not marking. Feeling as if I am not marking, but feeling as if maybe I'm marking.
That is right.
It's not me, and then she got mad. I think it's really funny when she wasn't mad at first, and then it like literally she look at all the process.
Just FYI, 4 questions on this, 2 on the front, 2 on the back. The 2 on the front you should be able to do with just the unit circle. You don't really need to use anything else. The 2 on the back you must use your calculator to do those. You will not be able to do it another way. Make sure before you get going too far, your calculator, you should check. Your mode, what mode should you be in for this quiz?
Radians.
Radians. What is the most recent homework you might have been attempting and dealing with? Degrees. Please make sure you check that and you're in the correct mode before you do the whole thing wrong and end up like, why did I get like crazy answers when I felt like I was doing this right? Easy mistake. You gotta get in the habit of checking that. This will not be the last chapter where we use both degrees and radians in the same. You press the mode button right next to the second is the menu you're looking for. Again, if you're not sure if you've got it the mode right, you can come talk to me. I'm happy to help you make sure that you're not like getting everything wrong because you had the wrong calculator mode going or something. You know? Maybe you don't. I don't know.